Om Namah Shivaya. We, the students of Group 3 from Class 9A, are going to present about Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction. These action and reaction forces are acting in two different objects in opposite direction, but they are having the same magnitude. Now, the members of our group are going to explain about some situations regarding the third law of motion.
Namaskar. I'm Daksh Baju of Class 9A, Group 3. I'm here to show you about the process of pulling off an elastic bench. One way to express the might be to stretch a rubber band. We hope the exercise will lead to the conclusion that the pulling force on the rubber band must be equal and opposite. This, of course, is Newton's famous third law. For every action force, there is always an equal and opposite reaction force. Thank you, Om Namah Shivaya.
Om Namah Shivaya. I am Advait Rajiv of Class 9A Group 3. I am here to show you about the process of hitting of a ball by a bat.
According to Newton's third law, the force exerted by the bat hitting the ball will be equal in magnitude but opposite in direction of the force the ball exerts on the bat. Generally, your arms are stiff when you hit the ball forward, so you will not feel the bat recoiling. A exerts a force on object B. Object B exerts a force equal in magnitude but opposite in direction on object A. Then, the ball on the combined forces of air pressure and gravity that act upon a ball hit in the air. The ball exerts an equal and opposite force on the bat. This is the reactional force. The ball forces the bat in one direction and the bat forces the ball in opposite direction. The two forces create an interaction pair on different objects and are equal in strength and opposite in direction. Thank you. Om Namah Shivaya.
Om Namah Shivaya. My name is Krishnananda of Class 9 from Group. Here I am going to explain the bouncing of a ball.
Do you know what happens when we place a ball on a table? A ball exerts a force on the table, and the table exerts an upward force on the ball. The magnitude of the two forces, that is, the force on the table and the force on the ball, are the same, but the direction are opposite. These forces are called action and reaction forces. The forces exerted by the ball on the table was an action force, and the force exerted by the table on the ball is the reaction force. What we saw here is an example of Newton's third law of motion. That is, to every action there is an equal and opposite reaction. A ball is able to bounce because of the reaction from the ground. If there were no reaction, then the ball would not bounce but rather stick to the ground. Thank you. Om Namah Shivaya.
I am Shreya of Class 9A Group 3. Here I am going to explain the recoil velocity of the gun.
This is based on third law of motion. The third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. These forces act on different objects and never on same object. The two opposing forces are also known as action and reaction forces. The statement for third law of motion is that to every action there is an equal and opposite reaction. Now, recoil of gun. The bullet inside the gun and the gun itself form a system. Before firing, the gun and the bullet are at rest. Therefore, momentum of the gun before firing is zero. When the bullet is fired, it leaves the gun in the forward direction with a certain momentum. Since No external force act on the system, so the momentum of the system must be zero after firing. This is possible if the gun moves backward with a momentum equal to the momentum of the bullet. That is why gun recoils or move backward. Hope you all understand this explanation. Thank you. Om Namah Shivaya.
Om Namah Shivaya. Myself, Sam Grieger of Group 3 from Class 9A is going to explain about a situation regarding the third law of motion. And the situation which I am going to explain is the launching of a rocket. Newton's third law of motion applies in different spheres of life. One of the situation in which third law of motion is applied is that of the launching of a rocket. All of you might have seen the pictures of the launching of the rockets, isn't it? You might have noticed hot exhaust gases and smoke flowing out of the back of the rocket's engine during its launch. As you know, Newton's third law of motion involves two forces, action and the reaction forces. Here, the flowing out of the hot exhaust gases and the smoke from the back of the rocket's engine is the action force. And this action force causes the rocket to move upward, which is the reaction force. These two forces, action and the reaction forces, are equal in magnitude but opposite in direction. The action and the reaction forces acts on two different objects in two different directions, but as we have discussed earlier, they are having the same magnitude. And so, as we have discussed, Newton's third law of motion is applied in the launching of a rocket. The same principle is applied in the flying of jet airplanes as well. Here, as you can see, a person is pumping water into the water rocket. And when this person releases the water rocket, it flies away very fastly. When the water gets pumped into the water rocket, the concentration of water molecules in the water rocket gets very high, and this water molecules creates pressure inside the rocket. As the water is being continuously pumped into the water rocket, the pressure also increases inside the water rocket. So, when we release the water rocket, the water inside the rocket flows with a greater force, which is the action in this case. And the reaction is that the rocket flies with a greater speed.
Om Namah Shivaya. My name is Amrita CS and I'm from 9A and I'm here to talk about swimming based on Newton's third law of motion.
Topic: Newton's third law of motion. Why does a swimmer push the water backward? Oh no, there is a hole in the boat. Now, how are you gonna reach the shore? Don't worry, jump in the water and push the water backwards with your hands. This will help you to move forward to the shore. No, you're not pushing the water backwards. See, you are moving forward to the shore. Do you know why you are able to move by pushing your water backwards? To understand this, you need to learn about Newton's third law of motion. Newton's third law of motion states that every action there is an equal and opposite reaction. No, not that action. Wait, let me explain. When we swim, we apply force and push the water backwards with the help of our hands. This is action.
In response to this action, the water pushes us forward with an equal force. This is reaction. First, in order to swim, move forward and the swimmer pushes the water backwards.
We hope you all enjoyed our presentation regarding the third law of motion. Thank you. Nam Shivaya.